Have you ever considered how much we rely on batteries in our daily lives and the enormous environmental impact of their disposal? Batteries, small but mighty, are the unsung heroes of our modern world. They power everything from our cell phones to our children's toys, making our lives easier, more connected, and certainly more entertaining. Yet this convenience comes at a cost. Each year, 15 billion batteries are discarded globally. That's 15 billion potential hazards, many of which end up in landfills, leaking harmful chemicals into our soil and groundwater. And while we've harnessed the energy of the wind and the waves for larger applications, these solutions falter when it comes to smaller devices. Can you imagine strapping a wind turbine to your wristwatch? But imagine a world where we don't have to rely on these traditional batteries for our small devices. A world where something as omnipresent, as ordinary yet extraordinary as sound could provide the power we need. But what if there was a way to power these devices not with batteries but with something as ubiquitous as sound? Scene script. Researchers at the renowned technical university ETH in Zurich, Switzerland, have made a breakthrough in this direction. Imagine a world where the simple act of speaking, of creating sound, could power your electronic devices. It's not a far-off dream but a tangible reality under development right now. The innovative minds at ETH Zurich have taken a leap forward by creating a mechanical sensor that harnesses the vibrational energy of sound waves and transforms it into electricity. This is not a simple task, as sound waves are complex and varied, but the researchers have managed to create a sensor that can selectively convert specific tones, words, or noise into energy. This means that not just any sound will do. The sensor is designed to respond to specific auditory triggers. Now, let's delve a little deeper into the technology. The sensor is constructed from a metamaterial, which essentially means that the sensor's unique properties are not due to the material itself, but rather the structure of the material. It's a beautiful blend of science and engineering where the structure has been meticulously designed using computer modeling and algorithms. The sensor is composed of a grid of identical silicon wafers, connected by minute rods that act as springs. These springs are the key to the sensor's functionality. They determine if a specific sound sets the sensor in motion, enabling it to convert the sound waves into usable energy. And here's the best part. The sensor is entirely made of silicone. It contains neither toxic heavy metals nor rare earth elements, which are commonly found in conventional electronic sensors. This makes the technology not just innovative, but environmentally friendly as well. In a prototype, the researchers demonstrated that their sensor could generate small electrical impulses when the word 4 was spoken. Other words like 3 didn't have the same effect. This specificity opens up a world of possibilities for how this technology could be used. So imagine a future where a small word, a specific sound, could potentially power your device. It's not just a dream but a reality that's being shaped right now. A small word, a specific sound, could potentially power your device in the near future. This isn't just a concept, it's a reality that's being shaped as we speak. The brilliant minds at ETH Zurich have already developed a successful prototype. This ingenious device created electrical impulses when the word 4 was spoken. It's fascinating, isn't it? But the researchers aren't stopping there. They're currently working on creating a sensor that can register up to 12 different words. Imagine a device responding to commands like on, off, down, and up, all powered by sound energy. And it doesn't stop at words. They're also pushing the limits of technology by developing a version of the sensor that is no bigger than a thumbnail. And the potential applications? They're as vast as the horizon, ranging from recording seismic activities to powering essential medical equipment. This sound-driven sensor technology isn't just a step towards a greener future, it's a giant leap for mankind.